Here we go. Section 1.4, complex numbers, quadratic equation, and the complex number system. Sounds so fun and exciting. So our objectives are to add, subtract, multiply, and divide complex numbers, and to solve quadratic equations in the complex number system. Okay. So by definition, we have what's called the imaginary unit. Okay. Imaginary unit, which we denote with an I, is a number whose square is -1. So I squared equals -1. Okay. And the reason why this is because -1 equals I. Does this look vaguely familiar? Complex number. Well, imaginary unit. All right. So complex number system are the numbers in the form of A plus BI. So A plus BI. Okay. A and B are real numbers, or coefficients are real numbers. And then the term with only the real number is called your real part. And then B is called your imaginary. So you have A plus BI. And this is my real. And this is my imaginary. Okay. And we do write it in this order to be mathematically correct. Okay. All right. So we're going to start off simple with adding and subtracting, and then multiplying and divide. So when we add and subtract, you're basically combining like terms. Okay. So when you're adding and subtracting, you're combining like terms. So if I have A plus BI equals C plus DI, obviously that means that my real terms have to be the same. So they have to be equal. And my imaginary terms have to be the same. So they have to be equal. Otherwise, would that be a true statement? No, it would not. It wouldn't. Okay, the sum of complex numbers. So basically with sum, literally you're combining like terms. So we combine like terms. Okay. So the sum of complex numbers means to combine like terms. Easy enough? Remember, these things are fully available on your Brightspace because we only have a 45-minute class. We can't write down everything verbatim on the board. Okay. Difference of complex numbers, it's a two-part process. So difference means you're going to distribute and then combine like terms. So you're going to make sure you distribute the negative and then combine like terms. So we distribute first, and then second, combine. Questions so far? Does this all look and sound familiar? Cool. Good thing it's.
I remember that.
I can. You want me to pull up on Canvas for you?
Yeah.
All right. So we have 4 plus 6i plus -1 plus 2i. Okay. Again, what did it say about adding? You're combining like terms. That's literally all you're doing. So I'm combining 4 with -1 and 6i with 2i. So that gives me 4 minus 1 plus 6i plus 2i. What is 4 minus 1? 3. What is 6i plus 2i? 8i. So my answer is 3 plus 8i. Questions? Easy enough? Good? All right. Wait. Oh man, I thought I put a subtraction one. I'm gonna have to make up a subtraction one. That's why it says A, because I had a B. But I guess I don't know what happened to my B. So if I had 3 plus 2i minus 8 plus I. So remember the steps here are you have to distribute first. So you're going to distribute the negative. So it becomes 3 plus 2i plus negative 8 minus I. Now, as you get better at this, you may not need to write every single step out, but for the sake of notes, I am going to write every single step out, okay? And then 2, you're going to combine your like terms. So real part with real part, imaginary with imaginary. So that gives me 3 minus I plus 2i minus I. So then my answer becomes negative 5 plus I. Questions about adding and subtracting? Does anyone feel like they need any additional examples of either one? All right. Now we're on multiplying. So multiplying complex numbers is just like before. When you're multiplying, you're going to use the FOIL method. But what you need to remember, key thing to remember is that when you have I squared, it equals negative 1. Okay, so we're going to do FOIL. So we have first 2 terms together. That gives us 6 times 3 is 18. We're going to do our outside terms. So we have 6 times 7i is 48i. We're going to do our inside terms. Gives us 15i. And we're going to do our last terms, which gives us 35i squared. Nope, it's 42. Making sure you were paying attention. Okay, and now we're going to clean this up. So we have 18 plus 57i plus 35 times negative 1. And why is it a negative 1? Exactly. It's I to the second power. So then we combine our like terms. So what is 18 plus 35 times negative 1? What kind of 17? We have negative 17 plus 57i. What are your questions about multiplying complex numbers? Key thing, we FOIL, and we remember I squared equals negative 1. Doable? Awesome sauce. All right. So what's going to happen when you do this? So this is the shortcut. So instead of FOIL, here's the rule that's going to follow. I think FOIL just, but here's the rule. When you're multiplying 2 complex numbers together, essentially, you're just doing A times C minus B times D plus A times D plus B times C. It's going to happen every single time. Or you could just go through the FOIL and remember I squared equals negative 1. Some people are formula minded and some people are process based. Does anyone plan on using the formula? No. All right. Now, complex conjugate. Okay. A complex conjugate is denoted by a variable, usually z, with a bar over it. And so if it says a plus bi, it just wants you to find the opposite operation. So if I'm adding, then it's going to turn into a subtraction. If I'm subtracting, then it's going to turn into a addition. Does that make sense? So the conjugate is the opposite of that behavior. So here, a plus bi equals a, the conjugate of a plus bi is a minus bi. So for example, if I had 2 plus 5i, and I asked for the conjugate, this is how I would ask for the conjugate, you would tell me it's what? That would be 2 minus 5i. That's your conjugate. Got it? Any questions about a complex conjugate? Okay, complex conjugate is going to be used when we're dividing. So just making sure we're comfortable with it. Oh, that's where I wrote it. I knew I wrote this example somewhere. I feel so slow. I was like, I thought I gave it to you. All right, so again, rewriting what I wrote on the other page. I have 2 plus 5i, and its conjugate would be 2 minus 5i. Okay. Now, if you end up with a conjugate times its, I don't know, a complex number times its conjugate, it's going to always be a squared plus b squared. So a complex number times its conjugate, it's going to come out to be a squared plus b squared. So for example, if I had 2 plus 5i times 2 minus 5i, when I multiply, it's just going to become a squared, which is 2, 2 squared, b squared, which is 5, plus 5 squared, which in this case would equal 4 plus, my nose itches, 25 equals 9. Okay, so that's what that theorem is saying. A complex times its conjugate produces a non-negative real number. Questions, comments, concerns? Oh, I don't know, guys. I forgot my 2. Why did I scribble out the 9? I forgot the 2, okay? That's what happened. In my mind, I saw it. Oh, man. All right. So next, we're going to talk about writing the reciprocal of a complex number in standard form. So right here, we have 1 over 4 plus 3i in standard form. And its reciprocal would be 4 plus 3i. Because what does reciprocate mean? When you reciprocate a fraction, what are you doing to it? You're flipping it. Okay, so when it says find the reciprocal, okay, so you think you would flip it, right? So normally, we're not flipping this, by the way. Reciprocal as a fraction is we just flip, right? Sounds easy enough. However, when you have a complex number, do you think it's going to be that simple? No, it's not. Womp, womp, womp. Okay, so to find the reciprocal of a complex conjugate, it involves a couple of steps. So step 1 is we have to find its conjugate. Okay, so that means we're looking for the conjugate of 4 plus 3i. And what is the conjugate of 4 plus 3i? You're so smart. 4 minus 3i is its conjugate. Okay, step 2 is we're going to multiply numerator and denominator by conjugate. Okay. So we end up with, and we're going to multiply the numerator by the conjugate, and we're going to multiply the denominator by the conjugate. And what did we say? What did our theorem say happens when you multiply a conjugate times, not complex times its conjugate? There you go. You get 4 squared plus 3 squared. So we end up with 4 minus 3i over 25, right? Okay. You do not keep it together. You actually separate. So your answer would be 4 25ths minus 3 25ths I. Please double check that I multiplied and added things correctly.
Yeah.
Okay.
No, you got it wrong.
I didn't forget my 2 this time. Thank you.
Actually, it's negative.
It's not. It literally says in the theorem, non-negative. The theorem tells us it's a non-negative, sir.
Maybe we'll do it for a second.
No, it's not.
No.
All right, questions about putting in standard form. Standard form is just basically saying you're not allowed to have an imaginary in the denominator. Do I have an imaginary in the denominator now? No. So we're now in standard form. We're in an acceptable situation. Questions? Does it sound doable? The 2 steps? Find the conjugate and then multiply. Find the conjugate, then multiply. All right. So, all right. We're gonna do A together, and then you're gonna do B. Okay. So we're gonna combine all the things we just kind of talked about into one big problem. Okay. So we have 2 plus 3i divided by 1 minus I. And again, is this proper form? No, because of why? There's an I in the bottom, okay? So step 1 is to find the conjugate of, that's not how I go. I goes that way. Find the conjugate of your denominator. And what's the conjugate of my denominator? Denominator one. It's okay. It happens to me as well. Okay, so the conjugate of the denominator is going to be 1 plus I. Step 2 is to multiply the conjugate to the numerator and the denominator. Mm-hmm. And then we end up with 1 minus I times 1 plus I. Okay, so in the numerator, you're going to have to FOIL or follow the rule pattern. And the denominator, you're going to use the theorem, right? So we end up with 2 plus 5i. I think I got 5. I won't shortcut it. I'll do it all the way through. And then this becomes 2 plus 5i plus 3 times -1. So my numerator is -1 plus 5i. And my denominator is super easy. I have 1 squared plus 1 squared gives me 2. Now, do we leave it like this as a whole fraction? No. If you try to put it in a whole fraction, Pearson will count it wrong because it's not in standard form. Standard form, your real and your imaginary are completely separate from each other. So you write it in two terms, -1/2 plus 5/2 I. Well, it's also math.
No.
1 squared plus 1 squared? Because I multiplied a conjugate times its complex. So you're going to square your coefficients. Yeah, and then you're going to end up with a negative times a -1 is a, and 1 plus 1 is? Yeah, it's 2. Look here, I know I'm a little slow, but I knew that part. All right, so I'm going to pause.